Right. So in this directory, I've only got E code, V code, and a text file. That's the E code. And that you should have all of those except for the ones that say my, because they're mine. We've also now got the source code of the Verilog with an extra file on top to wire it up to specman. So I think you've seen this before. And we've also got the specman environment here. But all the V code is now available, and that's the E code. And the only other thing I've got in here is the cheat sheet, which I will hand out after the break. That one there. Okay, so what we're going to do is we're going to look at the E code.
text a bit bigger before you move on.
Is that any better? Yeah? Okay. Okay. Okay, I want to start with this file, the instruction file. That might not be the top one, because that is in the order of how they're going to be loaded. What you've got there. But instruction is probably the one that we can closely relate to start with. And that is why I want to start with this one. Okay? So there's some code that you've already seen. What we want to do is we want to build a test bench for our calculator design. Now you know that there is opcodes, and we've already seen this enumerated type with the no operation, the add, the subtract, the invalid, invalid 1, shift, and shift right. 4-bit, and they're enumerated here where no op is assigned to 0, add is assigned to 1 implicitly. Okay? You can, if you want to do this differently, if you, for instance, didn't mention the invalids, you have to explicitly declare which bit pattern shift left and shift right are being assigned to. But because there's a continuous list, it's all right as it is. Okay, then we have an instruction struct, which should contain all the test data, right? And that is the operation that we want to run, the command, as well as the data 1 and data 2 item that we want to drive. Okay, so I'm going to declare an instruction struct to contain a field, command in, which is of opcode type, which we've just enumerated up here. And then I've got two fields, the first data item, data in 1, and the second data item, data in 2. They're both unsigned integers, 32-bit wide. And all three of them are physical fields, so if I wanted to pack this struct, then these are the fields that I want to pack into a bit string. And also they don't have an exclamation mark, so that means they will be randomly populated with data according to their types and according to any other extra constraints that I specify. So that would mean the opcode would be one of these, if I leave it further unconstrained, and the unsigned integers would be anything between 0 and 2 to the power of 32 minus 1. Okay, at the moment, that's how the types are defined. Okay? And then, of course, for each command I drive, I want to know whether a response was received, and with that response, whether any data was computed and brought to the output. So I keep two extra fields. One is called response, and the other one is called data out. Both of them are ungenerated fields, and we already know that these have to be ungenerated fields because they should hold the values that are produced by the design. And when they're produced, I'm going to grab them and put them into that struct, so that in one struct I know exactly the command, the two data items, and what the design returned. And I've got that in one struct. Okay? And then I've got a check response method which is currently empty. Any questions to this? Does that make sense?
What is the point of declaring a field physical? I understand that it's meant to specify that we're going to drive into the design and verification, but why? Why
Because the packing turns my high level, not add, subtract, etc., and my decimal 10 into the corresponding bit string.
So it's purely packing that stuff.
It's the packing that needs to know which fields to pack.
So if you didn't specify it, presumably you could still manually drive the design and pack it explicitly?
Yes, I think so. I'm not entirely sure because I would try it out. I would try to see whether I can I think you can. I think you can if you explicitly insist that a particular field is packed, you can pack it. But if you pack the struct, only the physical fields will be packed. That is certainly true.
Okay.
Okay. In many cases, it doesn't make sense to pack it together. For instance, if I wanted to pack the struct, I don't need a bit string that contains all three together. I typically want a bit string for each one of them individually, so I would have to pack them individually anyway.
Yeah. So is there much benefit to declaring them as physical fields, say then?
I think there's comment type benefits, to remind yourself that this is the data that you want to generate and that is the physical data. Right? And so you have to also be more diligent in terms of saying how wide they are. Right? Because if you're packing these, you need to say exactly how wide they are, and that is why this here specifies how many bit. Right? Because that is a 4-bit string for each one of these. Okay, any other questions? Now is the time to ask. Okay, so now I've said that the check response method is empty. Okay, the check response method is empty, but then now I'm going to extend the instruction struct, and I'm going to give you an example check for correct addition. That might not be perfect, but it's just an example of two things. One is how to extend something, and how to check something. Right? So I'm using variance control. So I'm saying when it is an add command, so when the instruction struct contains a command that is add, then what I want is the check response method over the instruction struct is only, well, I want to check that the response is a correct one, and I also want to check that the data that came out is the sum of the two data items that I gave it. And if that is not the case, then I can print it in all sorts of different formats, such as decimal and binary. And I can hopefully, by doing this, identify where the error is. And I print the command, the data in and the data out in different formats, so that I can see this in my error trace. And so if this is not satisfied, if the addition of the two data items gives me something else other than what the design produced, then this error message is written out. And this formatting of this string is very similar to printf. Yeah.
So, when you were talking about that trick earlier, if you wanted to verify that the response was one for all commands, would you have to use that trick?
Yes.
To specify the deployment point?
Yes, you would. The alternative would be to copy and paste it for each one of them, which is not a good idea. So you're better off saying, introducing a control field, a Boolean, that tells you what condition it is that you want, and then constrain that control field to that condition, and then using that control field up there. Yeah? The copy and paste is really a nightmare, because you maintenance, etc. In the third year, I don't think I need to remind you of what the problem with copying and pasting code is, right? So this is the way to avoid copy and pasting code.
And you've got the is only, previously there was also is also?
Yes, so I might have got something here already, right? That is always the case for check response. And then if I say is also, it does that first, and then it sort of, it appends whatever I say.
How do you prepend?
There's another one. Language reference. You've got the language
I was
reference.
looking at it, I can see it.
I can look it up. It shouldn't be difficult. There's the is only. There is also, and there must also be something that says
Is first.
is first. There you go. Yeah? So shall we now have a break? Yeah? We'll do a break now. This is the most important struct, right? And the nice thing about this is very much self-contained. I will show you later on how to extend this in a completely different file to collect coverage. Okay? Because at the moment we have said nothing about coverage collection here. But you can actually collect coverage without messing around with it. That allows us to have this as an orthogonal aspect, which we then can switch it on or off without messing around with this. That's quite cool. Okay, let's have a 10-minute break.